2as equals u squared minus v squared, or we can just bring these directly down here, divided by 2a. So s is going to equal to u squared, which is square root of 6.47, sorry, the 6.47 squared, which is 41.87 meters per second, minus 0, because your final velocity was 0, divided by 2a. And 2 times 9.8 was minus, well, 2 times minus 9.8 is minus 19.6. So what's your displacement going to become? 41.87 divided by 19.6 is equal to 2.13. Minus 2.13 or 2.13 doesn't really matter, or 2.14 rather. So 2.14 meters it's going to reach a maximum height of. So that's A. B says determine the time it takes to return to the ground. So to find the time, it's not enough room. I'm going to have to move to the right a bit, or there's no room either way. I might have to rub off some stuff. So to find the maximum, where's my paintbrush? Okay, determine the time it takes to return to the ground. So we've already got the height. We've got v equals 0 at the top. At the bottom we've got uy was equal to 6 point something, which I can't remember. I need to do this again. 25 sine 15. 25 sine 15. 6.47. And to determine the time it takes, we've got acceleration. Very simple, v equals u plus at. Why? Because I've got my v, I've got my u, I've got my a, and I'm trying to find t. So minus 9.8 t equals u minus v. T equals u minus v over t. Just year 8 algebra. U is 6.47 minus 0 over, sorry, this was a, which was 9.8. Let's see, that divided by 9.8 gives us 0.66 seconds. And that's your time. No, that's not your time, that's half your time. You have to multiply that by 2, which gives you the time of flight. So the time of flight is equal to 1.32 seconds. Okay, calculate the range. To find the range is just, if that's A, you shoot your projectile like that, and it lands at C. That's your maximum height, which is B. Your range is going to be from there to there, displacement. So now that we're dealing with horizontal, let's only think about the horizontal. We need to find ux. So if that was your initial velocity, which was 25 meters a second, that was 15 degrees, we need to find ux. And ux is just going to be the same thing as finding the opposite, finding the height of the right angle triangle. Instead of that, we need to find the adjacent, because ux is the adjacent, and that's the hypotenuse. So very simple. Instead of sine, we use cos this time. We're going to have 25 cos 15 equals ux. This was uy. Equals ux. So 25 cos 15 equals 24 meters per second. 24.15 meters per second. And since there's no acceleration in the x direction, all we have to do is multiply this by time to give us the distance, because remember, this distance equals speed times time. To find distance, take that out, it's a speed times time. So distance, or like that, is going to equal to speed times time. Our speed is 24.15 meters per second. Our time was 1.35 as far as I remember from what we calculated. 1.32, sorry, times 1.32, and we get 31.9 or 31.88 meters. and that's your range. So if we move to the next question, which is actually a HSC past paper question. A projectile leaves the ground at point A with velocity components as shown in the diagram. If it follows the path given by the dotted line, parabolic path, lands at point B. State the horizontal component of the projectile's velocity when it lands. Horizontal component is going to be the exact same thing as it first left. It's going to be 45 meters per second. Why? Because there is no acceleration in the horizontal direction. So it just stays the same. The velocity stays the same in the horizontal component. B. Find the magnitude of the initial velocity of the projectile. Magnitude of the initial velocity of the projectile. So that's what you're trying to find. Your angular velocity, your initial angular velocity. So if your vertical component is 40, your horizontal component is 45, very simple, Pythagoras theorem, u squared equals uy squared plus ux squared all square root, and we're going to end up with what? Let's say 40 squared plus 45 squared, square root of that, and sorry, this we've taken care of that with this square root, so that's just going to equal to 60.2 meters per second. What's the angle? We can find the angle, but it's not asking for it, it's just find the magnitude. Calculate the maximum height attained by the projectile. Maximum height, again, I'm going to call this point B and I'm going to call this point C, just to make it easier for me really. And I'm going to only deal with the vertical. I'm not going to care about this horizontal direction, so I'm going to pretend that I'm squashing the whole projector, the parabola, into one line, only the vertical components. And my initial velocity in the vertical direction is 40 meters per second. My final velocity in the vertical direction is 0 meters per second. Maximum height, we've got acceleration, which is going to be acceleration in the y direction, which is minus 9.8 meters per second squared. Don't confuse these two. This is horizontal acceleration, this is vertical acceleration. So we've got v, we've got u, we've got acceleration, and we're trying to find v, u, we've got a, we're trying to find s. So bringing this up here, s is equal to u squared minus v squared over 2a, which is going to equal to 40 squared minus 0 divided by acceleration, which is 19.6, and I'm going to get 81.6 meters. 81.6 meters up. That's my maximum height reached. 81.6. Calculate the range. Now, range is the horizontal distance here. To find the range, all we have to do is multiply the initial velocity, the initial horizontal velocity, with time. So we need to actually find time of flight. If it lands level with the starting position. Okay. If we find the time of flight, we just have to multiply the initial speed, initial velocity in the horizontal direction with the time. So we've got the same thing. I'm going to start from A to B. To find time of flight, I'm going to do v equals u plus at, because we know our final velocity is 0, we know our initial velocity, which is 40 meters per second, we know our acceleration in the vertical direction, and I'm working in the vertical just to find the time of flight. After that, I'm going to work in the horizontal direction. So 0 equals uy, which was 40, plus minus 9.8 t. So 9.8 t equals 40, t equals 40 divided by 9.8. which gives us 4.08 seconds. Now that's from A to B. But to come back, I need to multiply that by 2, and that's 8.16 seconds. So time of flight equals 8.16 seconds. All I have to do now is multiply this by this to give me the range. So range in the horizontal direction is equal to ux times t, which is your time of flight, and that's equal to 45 times 8.16, and 45 times 8.16 is 367.35, whoops, 367.35 meters. That's my range. So that would be D. And that's it.